contracting, going nova, creating new matter, increasing the expansion.
Yeah.
Which we can't explain why things are accelerating and seeming to continue to accelerate. Now, the way I believe they're continuing to accelerate is, imagine if you've got a bullet, you fire the bullet, that's your big bang. Yeah?
Yeah.
Expansion gases causing things to move away.
Yeah.
Now, within the gases that are moving away, we actually have planets forming, stars forming, they're collapsing, they're then going nova. It's a secondary explosion, which is then accelerating what is already moving. Yeah?
Yeah.
Because you're implying force onto a moving object.
Yeah.
But you're implying it in the force of the movement. Now, in a vacuum of space, things will only increase in speed if they apply more energy to them. They'll continue moving at speed until an equal or opposite energy moves against them. Right? Because we believe something has appeared from a finite point and it's spread out, surely every supernova that happens after that, in that initial blast, would cause the observable universe to accelerate away from that point. So you've already got it moving due to a first bang, which I don't believe is the first bang, but I'll get to that in a sec once you grasp what I'm trying to say.
Yeah, I see what you're saying.
Yeah, so you've got particulate matter moving out in the cone, the explosive cone.
Yeah.
It would be 360, but I'm expressing it as a shotgun blast.
No, I understand
to
what you
give
mean.
you a fixed projective. Yeah?
Yeah.
So then, imagine the pellets that are travelling out of the shotgun. Yeah? As the stars that are created. There's a lot more in depth than that, but imagine the pellets being the stars.
Yeah, you're oversimplifying it, I get it.
Yeah. Now imagine those stars breaking down and being themselves, in turn, a shotgun blast.
Yeah.
So that explains why it looks like the universe...
It's billiards on a pool table, Dave.
So that's why it seems that the universe is accelerating. To all intents and purposes it is, because there's combined energy coming in, and coming in, and coming in. But because space is finite, and gravity is the curvature of space, although we're seeing everything moving away, and moving away, and moving away, in reality, it's just moving around the universe. Things are just swirling. They're not getting faster. They're not getting slower. We see them moving away from us as speeding up continuously. But because we know space-time is curved, they're not going to move an infinite distance away from us. They can't. An expansionist universe says, yeah, they're just going on forever and it's creating space in front of it as it does it. We know that doesn't exist because matter is finite. We know dark matter exists, so matter is set. Yeah? No, we know dark matter is set. So you've had a bang. Now, people will say this is Big Bang. I don't believe that's the Big Bang. I believe you're just looking back to earlier in the shotgun blast, where another planet has just gone nova and it's propelled them that way. And another one's gone nova, it's propelled it that way. Another one goes nova, it propels it that way. Space-time is curved. What we are seeing is...
It's a spiral through a brain universe.
I wouldn't go that far. I think the Big Bang isn't the Big Bang, but what we're seeing is the largest optimal event that caused the trajectory we're going on at the moment. Because space-time is curved, we only see things in 3 dimensions, but we already know there's 4. We've proved there's 4.
We've proved there's more than that. But yeah.
I'm oversimplifying things. What we're seeing as a linear projection in one direction isn't. It's actually a spiral through space-time. Yeah? Because it's got to be a spiral through space-time, because time by nature is curved, because gravity causes it to be curved. What we consider the Big Bang wasn't the Big Bang, it was the last local supernova that affected our trajectory. Now, if it was the last effective supernova that affected our trajectory, then all we're witnessing other supernovas, and we're seeing that adding inclusive speed and velocity to different universes that it impinges on. but we're not seeing it affect us because light and time is that diffuse that it would take over 40,000 years for the closest star for us just to see that light to affect us. So we're not seeing the swirl in the eddy. Now, if
Can't see the forest for the trees.
but if you could actually see all the forces going off, space-time and the curvature of space and the gravity wells can be explained by dropping a drop of ink in a pool and staring at it. That ink seemingly moves.
You don't even need to do that. All you need to do is drop a ball on a piece of fabric that's going down, and it's your perfect example. But
No,
where it's spiraling
not,
in...
No, because that gives you a spiral. It's not a spiral. It's never been a spiral. Our minds want to make it a spiral. You're looking at a three-dimensional problem. A four-dimensional problem on a three-dimensional canvas.
No, because what I'm imagining is, you know, my grid that I did?
Yeah.
Is that, but,
No, but here's the thing.
Expanding on it.
That's
yeah,
you trying to visually interpret it onto 3 dimensions. We can't see a 4th dimension. That's like a 2D drawing trying to see 3D. It can't. It physically can't. There's an element we're missing. Like perspective, you know, if you were very close to something, you can't see it. But with perspective, you can see what's going on. We can't see the 4th dimension. We already know that. Yeah? I think when a supernova
no, we
goes
can only
off...
see the results of it.
Yes, exactly. We only see the results.
Yeah.
But because any form of light has taken 40,000 years to reach us, we're not seeing how everything is pushed around. We know that space-time is curved. We know that it's finite. We know that the universe we're in is a limited sphere. We already know that. We can prove that. Yeah? We don't know what is beyond that sphere. The reason we don't know what is beyond that sphere is we can't see the 4th dimension. So we can't actually see what shape it is.
Well, it's accelerating too fast for us to be able to see.
But it's not accelerating.
It's no, because of the light that comes through it, they can actually measure it.
No, here's my argument, and this is the whole part of the bit that kept me up all the other night. It's not accelerating. It's not.
What's it doing then?
It's moving away from the initial bang that has affected us. Our velocity is moving from the last supernova that has projected our matter in that direction. Yeah? Now, because this last supernova has projected our matter in this direction, there is other supernovas projecting matter in different directions. What we're not seeing is the universal swirl. What we've done with the Euclidean universe is we've believed that the world was the centre of the universe and everything moved around us, yeah?
Yeah.
Then we took another step and we believed that everything moved around the sun. Then we took another step and saw the sun was just a particle and it was moving around the centre of this galaxy. Now, when we take the next step, we'll believe that these galaxies are all just moving round because they're being propelled by the forces from each of the supernova that happen on regular basis in all universes. Now, if you get a